All right, so in this video, we're going to be learning how to deal with geospatial data in Tableau. So in basic functionality, how do we think about these things? How do we operate with these things? And in particular, how can we use the pieces of Tableau that we've already learned, like hierarchies and various visualization attributes, and bring these things into a geospatial domain. So to do this, we're going to be working with the COVID dataset. There are a couple like default datasets that are pretty good in Tableau, but I like this one better. Because it has a lot of good stuff, but it also has some not so good stuff. So like a real world data set often has some really bad stuff in it, and like bad in a good way, meaning things that you have to learn how to fix because this is the type of thing you encounter in the real world. So we'll see those in a future video. But for now, let's just review the structure. So we have the Johns Hopkins University COVID data set, which is has confirmed in deaths for states and counties for a fixed period of time that I pulled for you. Abbreviations and the corresponding region, so we can look at regional effects, election results, so you can tie it to red state versus blue state if you're interested in that type of thing, and then population numbers, so we can look at per capita statistics rather than raw statistics, because that matters a lot. So let's see how we do this. So let's go into our first sheet here. And in this sheet, you can see that Tableau has already auto-detected a number of different geospatial fields. And the way we can tell this is the little globe icon here. This is saying it, oh, I recognize this as geospatial. I'm going to act with it accordingly. So for instance, let's go here to state and county. First of all, notice that state and county has automatically been placed in a hierarchy. I don't think I did this on my own. If it doesn't happen on its own, for instance, right here, we have population, state and county. We can just drag the county into the state and say, oh, new hierarchy. Yeah, sure, that's fine. And here we have our new hierarchy. So you can create them if they don't exist already. But the important part is that it is actually a hierarchy, right? Like where each county belongs to just one state. But in most kind of like geospatial things, these types of hierarchies exist naturally. So let's drag this one from the JHU COVID datasheet into our data frame here, or I'm sorry, our visualization. You can tell I've been thinking about it all day. So this is the other side of data analysis, the quant side as opposed to the visualization side. So here we have what Tableau natively did. So it natively said, here I have some geospatial fields. I'm going to plot them in a geospatial way, which is really great. So right now, there's nothing else going on here. We have a marker for each state, which is fine. But notice, for instance, that we have a hierarchy, so we can interact with that hierarchy in all the ways that we're used to in kind of vanilla non-geospatial Tableau. So if I expand the hierarchy, for instance, I now have one dot for every county. I can collapse that back in, and I can change this. If I go up to the show me, I can change from what we're going to come to call a geospatial scatter plot form to a choropleth form, and we'll talk about what those mean, but basically it's like, do I fill in the regions or not? This is a big design decision, visually speaking. So let's keep it here, and we'll talk about the choropleth one first. So let's drag in confirmed. You could do confirmed or deaths, it's fine. But there are really two big options here. When you're thinking about how to visualize data geospatially, at least at first, you can either do it through color or through marker size. Those are the two big common ones that people do. If you do color, this type of figure is called a choropleth. It is a visualization, a geospatial visualization in which the saturation or color of the associated region is proportional to whatever value that we're tracking. So here it's proportional to confirmed. So in this particular case, I guess we'd say colder here. The darker the blue, the more the confirmed. And so in this particular data set, we can see that California, Texas, Florida, New York, these are very high confirmed cases in terms of states. But the amazing thing about Tableau and doing these things in this way is that because this is a hierarchy, we can actually expand this quite easily. And notice how much different the situation looks. So if I'm at state level here, and then I blow down to the county level, notice that even inside California, for instance, I'm going to actually just keep these, and my face is in the way. So let me do this instead. I'll go here. I'll just zoom in actually. Notice in California, the infections are not distributed equally. Northern California has basically none, whereas Los Angeles County has over 200,000. So like it looks, if we go to the state level, it's only telling part of the story, right? That, oh yeah, okay, yeah, California has a lot of infections, but then if you look within California, it's like actually Los Angeles County and the surrounding areas have the lion's share of that large number of cases. So there's a lot going on here. One of the things I don't like about Tableau is it's not very easy to move around. So you have to go here. See this thing here? And like this pans. Okay, that's great. And then you can zoom, and that's great. Man, whatever. You know, it's not super intuitive to me. I would think that there would be like a middle mouse or two-finger mouse, like pan option, but there is not. Small complaints, obviously, because this does so much good stuff. So this Choropleth option is helpful, and it does help you see kind of in a fine-grained way what's going on, and it does show you kind of in a more map-centric mode what's going on. It can sometimes be visually overwhelming, especially if you have lots of these little divisions like this. So one other way we often do this is instead of showing infections, for instance, by the color, we'll instead show it by the size. And this is very much in the, and see, notice that for me, it actually didn't switch over. So I actually want to go to like this. I had to click over again. So now I have a dot for each state, that the size of that dot now is related to the number of cases. This is the other common way. And again, if I were to drill down, it is still, in my opinion, fairly overwhelming to see what's going on here. But the good part with this, so the question is, why would we choose Choropleth over scatterplot or vice versa? The issue with choosing Choropleth is that color is now off the table. You can't use color for anything else. But if we use the scatterplot, we can actually use color for something else. So you could use, for instance, color by, oh goodness, let's not go there. But we could use color by region, for instance. So we could say region goes to color. I'm sorry, that's not what I wanted to do. That's just the count. So we could go color by region. So now we actually get the regions broken out. If we break this down to state, it's a little bit clearer. But you could get things by region. You could have you know, a lot of different kind of ancillary data included in this that helps you understand another aspect of the data set, a categorical aspect of the data set, in addition to the size of the thing under consideration, the confirmed cases in this case. So, and I said a categorical aspect of the data, but it wouldn't have to be, for instance, like you could do, and I'll just go there, it's fine. So we could, instead of doing region, I could do the number of people that voted for Trump in the 2016 election. This will be my color. And in this case, you know, this is obviously not the color scheme that I would want to show, because it's not as helpful. And this isn't even the thing I would want to show. I would probably want to show percentage of people voting for Trump or Clinton or whatever it was. But my point being that because we've allocated number of cases to size, we now have color left over. Whereas in a Choropleth, typically the goal is to just show, and I'll go back to that way of doing things. The goal in this case is to just kind of stop here. Like, we don't do anything else in a Choropleth. We kind of leave it here, because really what we're implicitly saying is the size is going to be geographic size. The color is going to be the quantity of interest, and that's where we're going to stop. Both of them are really good for their own reasons. It's just a design decision which one you choose. But notice what we've done. We've basically used hierarchies of natively identified geospatial data to allow users to drill in and out of the levels of detail, to go up and down in terms of level of detail for these things. You can operate at the state level or the county level. We can represent the quantity of interest. The numeric quantity of interest is either color in a Choropleth or size in a geospatial scatterplot. They have pluses and minuses. So in future videos, we're going to talk about what can go wrong here, and then how to spice this up even more. But in particular, how do we deal with these wrong data points or missing data points or something like that? It happens in every data set, so we just tend to confront it head on. But topic for another time, so stay tuned.